So now that this issue of a sample is so instrumental to statistics, let's talk about what makes a good sample. Or let's start by talking about not just a good sample, but the best possible sample. Let's say an ideal sample. So in this example, let's say we're trying to find what percentage of all 330 million Americans approves of the president, but we don't have the time or patience or energy to ask every single one. So then we gather a sample with a much smaller number, let's say 1,000 people. And of those 1,000, we ask, do you approve of the president? And from those, we're going to get a certain result. Let's say 41% approves of the president. So from there, we want to be able to trust that that number reflects the true number for the original population. So what about the sample that we collect needs to be true so that we can trust the results for the population? Yeah.
They're not all from like one specific area?
Yeah, very good. So one thing is that, for example, if we want to know what percentage of all Americans approves of the president, we shouldn't just stand outside Eastern Florida State College and ask, do you approve of the president? Because everybody who passes by and is part of that sample is going to be from Florida, from Melbourne, right? So we don't want everybody to be in the same area, but another way of saying that is we want our sample to be representative of the population. So. So when we say representative of the population, we mean that every aspect that we think is important in determining whether somebody approves of the president should be representative in the same proportions in the sample as they are in the original population. So for example, in terms of geography, if we have a certain percentage of people from each state, then we should have the same percentage of people in each state in our sample as well. So being representative of the population means that every attribute that we consider important, for example, geography, should be represented in the same proportion in both the population and the sample. So right now, geography is an important attribute. So this is in the context of when we say representative, we say that the sample is representative. We mean that all the important attributes are represented in the same proportion in the sample as they are in the population. Okay, so when we say representative, we're saying that all the important attributes are represented in the same proportion in the sample as in the population. But now, in this example, let's start coming up with what those important attributes might be. So we said geography was one of them. So what's another important attribute, you think? Yeah.
Economic class.
class.
Okay, good. So economic class. Good. Anything else?
Age.
Age, good. Ethnicity, good. So lots of things. Anything else? Yeah.
Occupation.
Occupation, great.
Gender.
Gender, great. Religion, great. Anything else? So you see lots and lots of things, right? And then, so when you're gathering this sample, so that you can trust the results for the population, you want to make sure that every one of these attributes are in the same proportion in your new sample as they are in the original population. But, and already you see this is very tedious to do, and to make sure that each of these are in the same proportions in the sample as they are in the population. But let's say that you take great pains to do this. You carefully construct your sample. All these things are accounted for in the same proportions. But then, let's say later on, weeks later, there's the research that comes out that says that there's some new attribute that you hadn't considered before. And I'm just making this up, but let's say what kind of soda they drink. But you didn't think about that when you gathered your sample. And so now that means your sample is not going to be fully representative in all the important attributes. So now, technically you would have to go back and redo your sample, regather your sample, collect new people in your sample now, because the one that you did before wasn't truly representative. So now the question is, when you gather a sample, do you truly know all the important attributes beforehand so that you can make sure they're in the same proportions in the sample as they are in the population? And if you can't really be sure, then you can't really ever have a good sample. And if you can't have a good sample, then you can't trust the results of the sample in order to make a prediction about your population. And this whole business of statistics starts falling apart. So, in order to save it from falling apart, what do you guys think is the answer to how we can guarantee to gather a good sample, or an ideal sample, and make sure that all these important attributes are in the same proportions without being able to know what all those important attributes actually are beforehand? Do you guys understand the question? Yeah, okay, so let me reiterate the question. So basically, we've been saying that the whole point of statistics is to gather this much smaller sample, like let's say 1,000 people, and be able to trust the results of your sample in order to make a conclusion about the population. And we said that one important attribute, one important characteristic of a good sample was that all the important attributes needs to be represented in the same proportion in your sample as in the population. And then we started listing out all the important attributes. And then we said that then to gather your sample, you then had to look at, for example, just geography, like what state they're from. And for example, if let's say we have 10% from Florida, then we have to make sure that in your sample we have 10% from Florida. And for, let's say, gender, if we have 52% female in the population, we have to make sure that our sample has 52% female. So we have to do that for all the important attributes. And if we can do that, then that's a good sample because it's representative of the population. That's what it means to be representative, is that for all those important attributes, they're in the same proportions. But let's say that later on, it's discovered that there's an attribute that you didn't think of that's actually important, but you didn't think of it at the time. For example, what kind of soda to drink. So now that soda factor is now not in the correct proportions in the sample as they were in the original population. So now we don't have a good sample and we can't trust the results of our sample. So the question is, how do we collect a good sample so that we can ensure that all the important attributes, including the ones that we didn't think of, are in the correct proportions? Yeah.
Random sampling?
Yeah, very good. So let's talk more about that. So it turns out that if you collect a sample that is purely random, which means that you don't discriminate or bias as to which people end up being in your sample, then it turns out that this issue takes care of itself.